Okay,
Yes, it looks great.
perfect. All right. Hello again. I am Lena Schmitt. I'm going to be talking today about the phenology of Asian longhorn beetle in South Carolina. Some background information. Asian longhorn beetle, or ALB, is a polyphagous wood-boring beetle in the Cerambycidae family. You can see those nice long horns. And it is an invasive species in both North America, Japan, Europe, basically all over the place, but it's native to China and Korea. And this beetle feeds on hardwoods from over 12 genera, so it's very much a generalist. But in North America, we've found that it almost exclusively targets red maple. Seems to really like the red maple. It does kill the trees that it infests, although a lot of the damage just comes from the structural damage that they cause by chewing their way through the wood. The life cycle, the females will chew an oviposition pit into the bark of the tree and lay a single egg underneath that bark. The females will lay up to an average of 50 to 75 eggs per year, but they do tend to lay one at a time. And when those eggs hatch, they turn into cute little baby grubs, and they start to eat at the vascular cambium of the tree. And they'll eat right at the surface, just underneath the bark, until about their third instar. So they make these nice big galleries on the outside of the tree, just underneath the bark, before they start to tunnel deeper into the hardwood. And they'll spend the rest of their time as larvae in the heartwood of the tree, eating away at the inner portions and causing lots of nice holes all throughout your tree. And then when they're ready to pupate, they'll chew closer to the surface of the wood and form a pupal chamber. And then once they've emerged as adults, they'll chew a circular exit hole and leave to go find a mate and a new tree of their own. In North America, there have been 16 populations found, including covering 6 states and 1 Canadian province. There's one up there in Toronto. All but 5 of these have been eradicated, which is really fantastic. It's a very controllable invasive species. The 5 that are left are 2 in Ohio, 2 up in the Northeast United States, and then the one that I'll be focusing on today is the one down in South Carolina that was discovered in 2022. And this is the furthest south that we found Asian longhorn beetle in North America, and that's pretty important because it's also the warmest area that we found it. So down on the coast, just southwest of Charleston, this is a 76 square mile federal quarantine that's been put in place. It mostly is through a little town called Hollywood. So I get to say that I work in Hollywood, which is fun. But again, this is the warmest climate that they've been founded in North America. Why does that matter? Well, we all know bugs grow faster when they're warmer. So that faster development speed also increases their population growth and their speed of spread, which is really not great things for invasive species. We don't really want them spreading faster. And so that accurate knowledge of their phenology when they're out in different life stages is really, really critical as well for effective surveying and eradication. If you go out looking for adults and the adults aren't flying at that time of year, you're not going to find any adults, and that's a problem. And also the management methods like insecticide use and biocontrol that are going to target specific life stages also need to be timed really accurately to be effective. If you're injecting an insecticide that's only going to work if the insect is eating at the vascular cambium, it's not going to work if the insect is already chewed deeper into the heartwood of the tree. So what do we know from some previous research? This was a modeling study that was done in 2016, and they created simulated ALB life tables based on laboratory calculations of the required degree days that ALB needs to reach adulthood. And what they found was that in the northern United States and in Canada, it can take anywhere from 1 to 5 years for those beetles to get from egg all the way to adult. But most often, we're seeing it take 2 to 3 years. So that's 2 to 3 years of them inside the tree, chewing their way through the wood. We also have this study from 2017 that used that same model to set up a map of the United States and figure out how fast are ALB going to be developing based on the climate conditions in different parts of the United States. And you can see we're down in that nice bright red area in South Carolina, and it was predicted in this climate condition that ALB could develop in as few as 8 months. So that's quite a bit faster than we're seeing in the more northern states. It's a very big difference from those 2 to 3 years. So my job, and this is a problem because, again, that faster spread makes the eradication more difficult. And also that less than a year generation time would cause the life stages to be present at different times each year. The adults would be offset by 4 months every year. And that would mean that any life stage specific control methods would also need to be applied at different times of the year. So it's really, really important that we verify whether or not this prediction is correct and then update that model so that we're working with accurate information. So what I am doing is collecting field data on the number of instars, the timing of those life stages, and the development speed. And then eventually we will be updating that model to make more accurate predictions for the southern United States. So every month from August of 2021 all the way until last month, December of 2022, I've been traveling down to Charleston, to Hollywood, and finding infested maple trees. And we cut those trees down and extract all of the ALB life stages that we can find. So that's peeling the bark and then splitting the wood on a wood splitter to make sure that we get both the larvae that are underneath the bark in those first couple of instars, and then also the larvae that have burrowed deeper into the heartwood. And then we take those larvae back to Clemson and measure the head capsule width in order to determine the age of the larva. And eventually, again, we'll be using this data to update the model. So what have we found so far? From the year and a half approximately of data that we've collected, we have found 87 eggs, 606 larvae, 24 pupa, and 2 unemerged adults. And then a huge thank you to USDA APHIS and Clemson DPI. They've given us information on when adults have been spotted during the flight season. So when they're no longer in the tree, but actually flying around in the woods. So here's what we found. I'll give a brief caveat at the beginning here. At the very beginning of our research, we were not collecting all the life stages of ALB. So you'll see that there's quite a lot fewer eggs in August of 2021 than there are in August of 2022. And that's because we were not collecting them with as much vigor as we were in the second year of collecting. So take that with a grain of salt. More than likely, that percentage of eggs in August of 21 should be a little bit higher. But you can see larvae are present almost throughout the entire year. They spend most of their time as larvae. And then we get a really nice, clear indication of those pupa and unemerged adults, April, May, and June. And then eggs starting to show up May, June, July, August, and September, and then dropping off as more and more of those eggs hatch and the larvae show up. And then on the top, you can see we have data from APHIS and Clemson DPI of the adults are flying April through July is the data that they gave to us. And then the head capsule widths. So the next quite a few graphs are going to be in the same format. The yellow behind is a histogram of the frequency of the head capsule widths of all of the larvae that I've collected over the year and a half period. And then the blue in front is just the month of the graph. So this is August 2021. And you can see that they're all generally in that range of about 2 to 3.5 millimeters. And then we get this beautiful progression as we go. September gets a little bit bigger and a little bit more variable. October, a little bit bigger, still quite a wide range of sizes. And then November of 2021, we had some really interesting stuff happen where we had a really large variation in the size of those larvae that we were finding. And there were even a couple of eggs in November, which means that even though the sightings of adults were only found through July, more than likely there are a few stragglers that are able to lay viable eggs even as late as November. Then December, again, we're getting even larger. January is when we start to about maintain the same size. February maintaining that same size, March maintaining, and then April, the larvae that are there are still maintaining the same size, but then we begin to see pupa and adults starting to emerge. May, we're no longer seeing pupa, although it's very possible that they're still out there and we just didn't find any. And May, we were not able to find any larvae, but it's entirely possible that we just weren't cutting down the right trees that month and just didn't get lucky, weren't able to find any. So it is possible that there are larvae present in May. And then June, we're seeing lots of eggs and our larvae are itty bitty. So all the way down at barely 1 millimeter head cap width. July getting larger, August getting larger, September even larger. October, again, we see quite a bit more variation and even some eggs present. So again, there are some straggler adults that are late enough in the season that they can be laying viable eggs in October. November, still quite a bit of variation, quite a bit larger. December, we've now hit basically the peak, and we'll continue collecting until next July, so that we get the full year, 2 years of data. But it's this really beautiful progression of, you can see them getting bigger and bigger and bigger until that stage where they hit the pupa and then the adults, and then they're back to very small larvae. So with that, we can really positively say that they develop from egg to adult in 1 year, pretty consistently, since we have such nice clean progression. There aren't any that we're finding that are a lot smaller or a lot larger than others. There is, however, quite a bit of variation in the larval size, especially in August through November. And I would love to know if that's comparable to more northern populations. Nobody has really done this kind of work. It's quite a bit of it is a lot of work to go through and cut trees down and pull out the larva. And oftentimes the eradications are happening so quickly that you only have a couple of years to get really good research in before the populations are low enough that you can't actually find them anymore. But I'd love to see more of this work happening in Canada if there are other infestations that pop up, or in the northern United States. And finally, we're seeing a single flight season in the year, beginning in about May, although the adults are most active May through July, those eggs being present in October and November suggests that the adults are also still out there until that late. So thank you all for coming, and a very many thanks to all of our technicians and collaborating agencies. Couldn't do it without them. Does anyone have any questions?
Thank you so much, Lena. That was a great presentation. If you have questions for Lena, please pop them into the Q&A box and I'll read them out loud. We do have one here already. Any idea what the rough percentage of tree mortality is per egg-laying beetle?
That you're asking, like, if a single beetle infested a tree, would it kill the tree?
Maybe that's all the
potentially.
Yeah, if that's not it, then maybe they can write back and clarify.
Sweet. If that is it, a single beetle is probably not going to kill the tree. The main cause of tree mortality is just the structural destruction. So they'll circle the whole tree and cut off the flow of water and sap. They'll also just basically put Swiss cheese holes through. So like the whole top of the tree will come down because there's no structure inside to support it. And then eventually they do also have to deal with problems like more secondary infections of fungus, other colonizing insects, that kind of a thing. So it tends to be more the combination of a lot of different impacts, either tons of beetles happening all at once or those secondary infestations that are causing the death.
Yeah, yeah, that makes sense. This person did write back and clarify. They said, I mean, if one beetle lays 50 to 70 eggs, how many of those beetles would end up killing a tree or larva?
Okay. I mean, it would be them all working together, and the females do tend to lay, like they'll all lay on a single tree. So if one female lays on a tree, other females will also come, and they tend to light up that single tree. But it would be a process of them all working together.
Yeah, yeah, for sure. That sounds good. I don't see any other questions here in the chat. I'll ask maybe one of my own here. We have had some run-ins with ALB here in Ontario. Thankfully, it's still declared eradicated, but just because they're not here now doesn't mean they never will be. Again, would you be able to touch on some of the common pathways of the ALB just to give people an idea of maybe what they could look out for or what they should be mindful of?
Yeah, absolutely. This is a big one where you really don't want to move firewood. They're often, we think, although it's not super clear 100%, but we're pretty sure based on genetic studies that the infestation down in South Carolina was most likely, again, not 100%, but most likely came from one of the Ohio populations, especially because we do have a pretty high population of campers and tourists coming from Ohio down here for vacation. But also things like if you're by a port, that's pretty common to get them directly from China via packing material, crates, dunnage, that kind of a thing. So anything wood is going to be a vector for them.
For sure, that makes sense. Thanks so much. Another question here. Does maple bark show early signs of infestations, just like EAB, with bark getting sloughed off by squirrels and birds?
Not as much. We do see some evidence of especially sapsucker damage and some woodpecker damage. But because they travel deeper into the heartwood, whereas EAB stays on the surface just under the bark their whole lifespan, a lot of times they move so quickly into the heartwood that a lot of woodpeckers just cannot access them. So they're not available to be eaten after a certain point of time.
Right. Yeah, that makes sense. Thank you so much. All right. Well, I don't see any other questions here, but we really appreciate your time, and it was an excellent presentation.
Thank you.
All right. So with that, we will be wrapping up this session here. If you have any other questions, or if you want to learn more about specific species, then I suggest you check out our risk assessment database or our best management practice database. These databases really just provide a record of completed risk assessments and best management practices relevant to North America. So they've been created by different government and non-government organizations, and you can learn more on our website. I will pass it back over to you, Mackenzie.
Thank you, Madison. I hope everybody enjoyed that great session. We're going to move into a little 10-minute break. So we're going to reconvene at 3:00 p.m. Eastern Time for our Indigenous Communities and Organizations session. Really excited to dive into some of the really great work happening on First Nations here in Ontario. And just another note, I've been talking about this all day because I'm really excited about it. But this next session is going to end with a woodland style florals workshop with Lucy LaFord. So please join that session and bring a piece of paper, pencil eraser, and pencil crayons or markers for that workshop as well. So looking forward to that and looking forward to seeing everybody there at 3 p.m. Thank you.